Okay students, in the last session I defined one-to-one and many-to-one based on the domain. Okay. Now in this session I am going to define three more function types, namely the into function, onto function and one-to-one and onto function. Into and onto I will be defining it based on the domain. Just look at the definition of an into function. A function f which has a mapping from A to B is called an into function. When is it called? If the condition is this: if there exists at least one element in set B. Set B is the codomain here. Set B who does not have a pre-image in set A. The pre-image is present in the domain. So you understand that the codomain, there is at least one element left out without being mapped with the elements in the domain. So this is what we call an into function. Okay. Next I will show you an example for an into function. An example for the into function. We have two sets here, S and M. I will explain to you what are these what these elements within the set represent. Okay, so I considered the set S to be the students in the 10th standard. So I have not written the names here. I have named them as S1, S2 and so on. So we have 5 students there. And set M represents the marks, the scores the students can obtain. So what will be the minimum mark a student might obtain? It might be 0. And what will be the maximum mark according to our Indian standard system, education system? The maximum mark that can be obtained will be 100. So set M will be having numerals from 0 to 100. Now I am going to show you the mapping under this particular function, namely obtained. So I have 5 students, namely S1, S2, S3, S4 and S5. I am going to define this function based on the codomain. You have 0, 1, 2, 3 and say you have 50 and then 75 and then 100. Okay. So this set what is the name of the set? This is S and this is M. Mapped by the function f. So I will name this function as obtained. Okay. For an example, let's say S1 has got the score 50. S2 has got a score 1. S3 has got score 75. And S4 has got score 100. Okay. And then S4, S5, I'm sorry, this is 5. So S5 has got score 3. Shall we define it? What does an into function say? It is a function. It is a function. And say there are some elements in the codomain which say do not have a pre-image. Now according to this example, the element 1 in the codomain has a pre-image which is S2. Element 3 in the codomain has a pre-image S5. Element 550 in the codomain has a pre-image S1. Element 75 in the codomain has a pre-image S3. Likewise, element 100 in the codomain has a pre-image S4. The other elements like 0, 2, 4, 6 and so on, those elements do not have a pre-image in the domain. Okay. So here there are so many elements that do not have a pre-image. So according to the definition, if there is at least one element in the codomain that does not have a pre-image, then that mapping we call it an into function. So let's define an onto function based on the codomain. What is an onto function? It might otherwise be called as a surjective function. A function h which has a mapping from x to y is called an onto function. If, be very careful about this, say condition, if every element of y, what is y? Y is a codomain. Every element of y has a pre-image in x. X is a domain. So what do you understand from this definition? No element in the codomain should be left without a pre-image in the domain. I'll show you an example for this. Once again, here I am showing you a real-time example for an onto function. See, when you look at this, most of you might be knowing what I have written within it. They are nothing but the models of the vehicles. Okay. So look at the set X. Set X has MB, AMG, MB, GLE. What is it? It is nothing but a model being manufactured by the Mercedes-Benz company. Okay. So BMW X5 is a model being manufactured by the BMW company. Likewise, 800 is a Maruti company producing product. Okay. Producing model. Now, why? I have only three companies, the name of three companies, namely Mercedes-Benz, BMW and Maruti. Only three company names I have written within the second set, that is nothing but the codomain. I am going to show you the mapping between these two, and I am going to prove that it is an onto function. Okay, let's consider the codomain. What are the elements present within the codomain? Mercedes-Benz, BMW and Maruti. Only three elements are present within the, say, codomain. Now let's show a mapping based on manufactured by. So MB, AMG is being manufactured by Mercedes-Benz, likewise GLE, GLC. Then BMW models are nothing but X5, X3 and M5. 800 and Desire are models being manufactured by Maruti. So let's define the onto function. Looking at this diagrammatic representation, start from the codomain. This is a function, h is a function, okay, and it is called an onto function since every element of the codomain has a pre-image in the domain. In another way, there are no elements in the codomain that do not have a pre-image. Just look at this example. Are there any elements being left out in the codomain without a pre-image? No, nothing of that sort. Every, say, element in the codomain has a pre-image. It has gone under the mapping, and that's why it is called an onto function. Okay, the last definition is nothing but the one-to-one and onto function. It is otherwise called a bijective function because it involves the definition of both one-to-one as well as onto. So, how shall we define it? A function f, which is being a mapping from A to B, is called a bijection if it is both one-to-one and onto. For this, we'll see a proper example. So now I'll explain the one-to-one and onto function based on the algebraic notation of a function. Okay. So in this example, you'll be able to understand how to calculate, manipulate the values and then find out the domain, the range as well as the, say, what are the values present within the function. Now this is written in the set builder form. The function is written in the set builder form. According to this, what do you understand? It is x comma y. It is an ordered pair such that, okay, the value of x ranges from 1 to 5. Inclusive of 1 as well as inclusive of 5. And what is the function? The function is defined like this. 2x plus y or 2x plus 3. So now shall we calculate the values of the function? And one more, say, condition is being mentioned here. X and y come from the natural numbers. So natural numbers, naturally, you know, starts from 1, 2 and goes up. Now, what are the elements of x? So x can take up the values 1, 2, 3 and 4. So shall we frame the set? So the set x will be having the elements, namely 1, 2, 3, 4 and 5. Now I should calculate the values of the y using this function. So substitute 1 in this particular function. So what will you get? So 2 into 1 plus 3 is equal to 2 plus 3, which is equal to 5. So what is the, say, image you'll be getting? You'll be getting 5. For which particular number did you get this image? When you substituted x as 1, okay, you got the image as 5. Likewise, proceeding further, substitute x as 2 in this function, you'll be getting 2 into 2 plus 3, which is equal to 4 plus 3, which is equal to 7. So you'll be getting 7 here. Likewise, substitute 3 here, you'll be getting 2 into 3, 6. 6 plus 3, 9. 9 is the next image. 4. 4 into 2, 8. 8 plus 3, 11. Next, 5 into 2, 10. 10 plus 3, 13. That's it. Okay. So, with this, I have framed the, say, domain set as well as the codomain set. Now, let's show the mapping between the domain and the codomain, and let's verify whether it is satisfying both one-to-one as well as on-to. Look at this arrow diagram. Through this arrow diagram, you'll be able to understand this one-to-one and on-to function very clearly. So, the set, domain set has got the elements 1, 2, 3, 4 and 5, while the codomain set has got the values 5, 7, 9, 11 and 13. I have already shown you how you got this 5. Okay. It was applying 1 to this function 2x plus 3, you got 5. Applying 2 to this function, you got this image 7. So let's define based on the one-to-one. Is this mapping a one-to-one mapping? Yes. Distinct elements in the domain has got distinct images in the codomain. Okay, so it is one-to-one. Let's check whether it is on-to. According to an on-to function, say that every element in the codomain should have a pre-image in the domain, or otherwise there should be no elements in the codomain that do not have a pre-image. Is any element in the codomain left without a pre-image? No. Every element in the codomain has a pre-image. Therefore, this particular mapping is also onto. So, together how do we call them? We call them a bijection. Together how do we call it? We call it a one-to-one and onto function. Okay, students. So, in this section, I hope you understand what we have dealt. We have dealt about the various types of a function. Okay. In the next session, I will show you some examples of different functions. Functions being represented by means of an algebraic form, as well as I will show you how to test whether it is a function or not through a particular test, a vertical line test. And also we can test whether a particular function is a one-to-one function by the horizontal line test. Okay.